Okay, in the last section of Module 5, we're going to go to the law of cosines. Now, in the previous sections, with the law of sines, we were able to solve triangles where we had two angles and a side. So either the side in between the two angles or the side not in the non-included side between the two angles. And then we also had the ambiguous case where we could have no solution or two solutions of SSA. So in section 5, we're going to try to solve oblique triangles in any triangle using a different set of given information, namely if we have all three sides or if we have two sides and the included angle. Now this is different than our SSA, because in SSA the angle was not between the two sides. In SAS the angle has to be between the two sides. So for example, if we know side C and we know side A, let's say, to do SAS, we would have to know angle B, while previous, we'd either know angle A or angle C. Now, in general law of cosines, there's not as much ambiguity as far as, two solutions or one solution. There's pretty much always one solution. But what we have to do is we have to use slightly more complicated formulas. So the law of cosine follows as this. We have a squared equals b squared plus c squared minus 2bc cosine a. And then you could switch the variables around. But the main thing is, whatever side by itself here, which is squared, you have to have the same angle over here. And then whatever other two sides you have them squared. And then we have those same two sides multiplied right there. So these are both the law of cosine. All these are the law of cosine. So, and you can do this for any of them. So if I was just to pick a generic triangle with different letters, we can show you how the law of cosines would also hold. So let's say I had I, J, and K. Well, this is little I, this is little K, this is little J. So if I wanted to find J, let's say, then we know J squared equals the other two sides squared, so k squared plus I squared, minus 2ki, because it's the same two sides on that side, cosine of angle J. So this is the way you can kind of quickly remember how the law of cosines work, but it only will work if you have side angle side or side side side. So let's look at an example of each of these. Let's first look at for side angle side. So in this case, I have angle 51. I have side little c. Little c is 23. And little a, which is 7. So what I have to find here is I have to find B, I have to find angle C, and I have to find angle A. So if I look at B, B is the missing side, and I can use law of cosine because I have side, angle, side. I have the angle in between. So when you're using law of cosine, and you have two sides, you can very easily find the third side. I will use the law of cosine that involves b squared, because I'll use this one because I only have one angle, angle B, and the only law of cosine that has angle B in it is the one that starts with B. So b squared equals a squared plus c squared minus 2ac, because those are the other two sides, times cosine of big B. So I always would encourage you to write the formula down before we start plugging things in. So now if I do this, I'm going to get b squared equals a squared, which is 7 squared, plus 23 squared, because that's c, minus 2 times 7 times 23 times the cosine of 51. Now, everything on this side, everything you see over here is just simply a number. So that's going to give me b squared equals 375.36. We'll just round to 2 decimals. And then to get b by itself, I'll simply take the square root of that answer. So b is going to be 19.37. And again, you should always look what you need to round to. on most of these problems. So now I know what B is. B is 19.37. So now we have some choices. Now what we can do is we can continue using law of cosine, or now because we have all the sides and an angle, I could actually go back and use law of sines. Either way will get you the same answer, but just since we're using law of cosines, we'll just stick with that and see what we get for angle A and angle C. Really, I only have to find one of them, because the other one I can find by 180 minus the other two. So we'll go ahead and find angle A. So if I want to find angle A using the law of cosines, I have to pick the law of cosines that has angle A in it. And that's the one that'll start with side A. So A squared equals B squared plus C squared minus 2BC times the cosine of angle A. So angle A is really what I'm trying to find. And doing the problem this way will really set us up to be able to do our second case when we have all three sides. So side A in our case, if we go back up here, side A was 7. So this is going to be 7 squared equals B squared, which is 19.37 squared, plus C squared, which is 23 squared, minus 2 times 19.37 times 23 cosine of angle A. Now how this typically works, we typically do this in three parts. We're going to have the little square on this side. We're going to have these two squares that are added together, and then we're going to have these numbers that are multiplied. So I'll first look at 7 squared. 7 squared is 49. I'll then do 19.37 squared plus 23 squared, which is going to give me 904.20 minus 2 times 19.37 times 23, which is negative 891.02 cosine A. Now you have to be very careful at this step, because what a lot of people will do is they will just subtract these two numbers, but you cannot do that because you have this cosine A at the end, which works kind of like a variable. So the key here is what we'll do is we'll actually subtract the 904.2 from both sides. So we'll do 49 minus 904.2, which is going to be negative 855.2. Equals negative 891.02 cosine A. And then we'll simply divide both sides by the number in front of cosine A, which is negative 891.02. So what I end up with is I have cosine A equals 855.2 divided by 891.02. And so now going back to basic geometry, when you want to find the angle, when you have the ratio, we'll use the inverse. So just like we did for the law of sines, we'll do the inverse cosine of 855.2 divided by 891.02. And again, make sure your calculator is in degree mode. Make sure you're getting 16.3, which is what I got. I'm going to take the angles to 1 decimal point. So 16.3 degrees for angle A. So if I go back up here, I know angle A is 16.3. And that goes right there. And that's a pretty small angle across from the smallest side, so that kind of makes sense for what we talked about earlier. So lastly, we just have to find angle C, but angle C is just going to be the supplement of the other two. So angle C is going to be 180 degrees minus 51 minus 16.3, which gives us 112.7. So angle C is 112.7. So I've now solved this triangle by finding all its sides and all its angles. So the only other case we have to look at is we have to look at the case where we have all three sides given, where we start with all three sides and we try to find all three angles. So when we look at the second case, all three sides, in this triangle we have 10, 15, and 22. So the 15 is our little b, it's across from angle B. 22 is our little c, and 10 is our little a. Now in this case I have to find all the angles, and again I really only have to find two angles because then I know they all add up to 180. So we're going to use a really similar process to how we used the law of cosines on the last problem to find that second angle. So what I'll do is I'm going to find, just for without loss of generality, I'll find angle A. So I'm going to start with the formula a squared equals b squared plus c squared minus 2bc cosine angle A. Now I'm just picking the one that had angle A in it, and then I'll just plug some numbers in. So 10 squared equals 15 squared plus 22 squared minus 2bc, so that's 2 times 15 times 22 cosine A. And again, like we talked about on the last problem, let's look at this in chunks. So 10 squared, that's a pretty easy one, that's 100. 15 squared plus 22 squared is going to be 709. This is just stuff you could do in a calculator, you could work it out. 2 times 15 times 22 is negative 660 cosine A. I'll then move to the other, I'll move the 709 to the other side, so I'll subtract 709, and you get the same process that kind of repeats itself in all these problems. Negative 609 equals negative 660 cosine A. And then I'll divide both sides by negative 660. So we end up with the cosine of A equals 609 over 660. And so of course now I can use a similar process. I have the ratio, I want the angle, so I'll use the inverse cosine of 609 over 660. So angle A turns out in the calculator to be to 22.7. Again, I know I keep saying this, but make sure your calculator is in degrees or it's not going to give you the correct answer. So on our problem up here in our triangle, if I just want to write the angle measurements in the triangle, I know this is 22.7, which is across from the smallest side, and that's a pretty small angle, so that makes sense. We'll check when we get the other ones to make sure that it is the same. So now I just have to find another angle, and I could use either B or C. So I'll do B, just because that's next alphabetically, no other good reason besides that. So if I'm finding B, I'll use B squared equals A squared plus C squared, the other two sides, minus 2AC cosine angle B. And then I'll plug these things in. So side B in this case is 15, so 15 squared equals 10 squared plus 22 squared. And again, just plugging it in from the triangle, minus 2 times 10 times 22 times cosine B. Same idea when evaluating it. I'm going to look at these three chunks individually so I don't get those confused. So 225, 10 squared plus 22 squared is 584. 2 times 10 times 22 is negative 440 cosine B. And so now I'll move 584 to the other side. So I get negative 359 equals negative 440 cosine B, and I'll divide by negative 440. So cosine B equals 359 over 440. So same idea, B is going to equal the inverse cosine of 359 over 440. The inverse cosine of 359 over 440 turns out to be 35.3. But of course you should check for yourself and make sure you get the same thing. So now I can come up here. I know angle B is 35.3. And of course now for angle C, I mean you could do the law of cosine again. That seems like a lot of work because you could just do 180 minus 22.7 minus 35.3. And we get angle C to turn out to be 122 degrees. So law of cosines is a really nice formula, a really nice way to solve these triangles. Again, the key thing is just to remember when you're doing law of sine and cosine to know what information you're given and then which set of formulas to use to solve it. If you have any questions on the law of cosine, please let me know.